Yeah, so my name's Don Hagan. I'm an associate professor of forest ecology at Clemson University. And one of the topics that's come up in a number of talks so far is fire seasonality. And so I want to kind of drill down into that a little bit deeper and talk about burning in the early growing season, and is it an option worth considering? So what I'll be presenting on today is some results of a study that we've been doing for the last couple years. A couple of graduate students, one of whom is here today, Allison Melcher. So some of this will be some highlights from her work. And then Matthew Vaughn, some of y'all might know Matt. He graduated not too long ago with his master's. Just a little bit of background on this study. In 2015, the Consortium of Appalachian Fire Managers and Scientists identified prescribed fire seasonality as their number one research priority. So there was a grant opportunity that came out through the Joint Fire Science Program, and I was fortunate enough to get some money to fund some prescribed fire seasonality research here in the Southern Appalachians. And the focus of that initial project was really three things. One is just fire behavior, right? How do early growing season burns differ from dormant season burns with respect to their fire behavior? Also fuel consumption, the vegetation response, particularly focusing on some of those quote-unquote undesirable species like mountain laurel and red maple that many land managers are trying to control, but also the herbaceous species in the understory. And then more recently, and this is getting into some of Allison's work, starting to look at birds and how birds might be responding to these changes in forest structure that are caused by burning in different seasons. Before we get too far into it, I should kind of define and talk about what we mean, or what I mean when I talk about seasonality. You know, for the most part, in the Southern Blue Ridge, where I do most of my work, the majority of your prescribed burning has traditionally been done in the dormant season. Right? During that time of year, when your dominant overstory deciduous vegetation is without its leaves. Right, but there was some interest among many land managers to explore burning outside of the traditional dormant season. And so we wanted to look at, okay, what if we burned during the early growing season, right? And the early growing season, I'm defining as sort of that spring green-up period. So after those buds have swollen and broke and the new leaves have emerged, but before you get into early and midsummer when you have complete canopy leaf out. As we saw from one of our previous talks, you know, there are some concerns, some valid concerns, I think, about burning in the early growing season, especially when you're talking about, you know, the reproductive calendars of many of your wildlife species of interest. But there might also be some benefits and some reasons to consider it. One of them could just be logistics, right? Really, because when you talk about burning in the early growing season, what you're really maybe talking about is just adding a little bit more time to your existing burn season. Okay. And maybe you want to burn in the middle or late growing season. That's, you know, there's valid reasons to want to do that as well, but there might be some challenges if you want to do that, right? Because especially in the Southern Blue Ridge where it rains a lot, in the middle of the growing season, when you get complete canopy leaf out, it stays pretty humid there on the forest floor, and those fuels might be harder to ignite. You sometimes might have some air quality concerns as well. It might be harder to put smoke up in the air that time of year. So the focus of my study is just the early growing season. But that's not to say that there aren't other seasons during the year when you might want to consider burning. I think there's a good ecological basis for growing season burns, because if you look at just the historic fire regimes of the East, you see that fires historically happened really throughout the year, right? They weren't confined to just a couple months during the dormant season. And this is a graph that I lifted from a publication that actually is available out there. It's Charles LaFawn's Fire History of the Southern Appalachians. And if you look at this graph, there's a lot going on, but you can see there's sort of this bimodal pattern of fire, right? So if you look at acres burned, or if you look at just the number of fires per month, right, there's sort of two peaks. One of them is in sort of the late spring, and the other is in, sort of the late fall, right? Those are the times of year when your relative humidities are usually the lowest and your ignition probabilities are the highest. But really, there's hardly a month, right, when fires don't happen. All right, fires would happen almost any time of the year. Now this graph I think is from Virginia and West Virginia, but I think it probably translates to down here as well. I think there's a good management basis for burning outside of the traditional dormant season as well. I've done a lot of dormant season burning, a lot of projects that have focused on dormant season burning, and what we've seen by looking at some of the data is that these dormant season burns, they do a good job of reducing fuels. But the changes to forest composition, which is one of our other goals a lot of times, right? We want to manipulate forest composition. Those changes are often pretty modest, right, when you're burning in the dormant season. Even if we're talking about repeated burns. I'm not saying that dormant season burns don't do anything, but sometimes the rate of change doesn't line up with the rate that we would like to see things changing. And we got to keep in mind, that these forests have gone a long time, many decades, without hardly any fire. All right, there was a long period of fire exclusion, that we're all familiar with. And so these forests, in many cases, are quite departed from what they historically were, quite departed from what we would like them to be in the future, right? You've got encroachment by what we call mesophytic hardwoods. You've got the expansion and the spread of mountain laurel all over the place, dense thickets of mountain laurel developing all over the place. And so that might necessitate a different approach, right? We might need to open up the toolbox and think about some additional strategies that we can implement above and beyond just dormant season burning. And if nothing else, though, expanding our burn program outside of the dormant season to include some of the growing season, if nothing else, it might give you a longer annual burn window. Because I work with a lot of folks that have really ambitious burn plans. I don't know if any of y'all know Wes Bentley in the Andrew Pickens Ranger District at the Sumter. I mean, that guy, he's probably burning right now. So, if you've got ambitious burn plans, you're trying to expand the pace and the scope of your burning, we need to capitalize on every potential burn day, right? We've heard a lot of talk about 1 million acres in Georgia that are getting burned, or over 1 million, and that's a lot. But that's just a tiny fraction of the land that needs to get burned. So maybe we need to look at some additional burn days. So that brings us to the study design, and before I get into this too much, I do want to acknowledge some of the people who made this study possible. Some of them are here today. Nick Peters and Mike Brode were tremendously instrumental in pulling off the burns that we were able to do. Also Wes Bentley, Helen Moore, and many others. Basically what we did here was a large landscape scale experiment where we have, I can't really walk around and point at the board, but I'm going to try to use the pointer. We have 3 treatments, 3 little clusters of 3 treatments. We've got an early growing season burn unit paired with a dormant season unit, and then paired with a control unit that was unburned. And we have these, so this is replicated 3 times across an elevation gradients from some pretty high elevations up here in the War Woman area of the Chattooga River Ranger District, right there. Moving down an elevation through the Andrew Pickens Ranger District in South Carolina, and then we had an additional just standalone dormant season unit there in the Chattooga River Ranger District. So a total of 7 burns. These are our burns. We had no burns in 2016 or 2017 due to drought or wildfire concerns. All the burns that we'll be talking about today happened in either 2018 or 2019. The total acreage burned for this project was just under 6,000. Our dormant season burns, those 4 dormant season units, added up to 4,300 and something acres, and then about almost 1,600 acres of growing season burns. So those growing season burns were a little smaller, but still some pretty decent sized units, one of which, Duck's Nest Gap, Nick was there for that one, over 1,000 acres we burned in the growing season. And again, we set it up as an experiment because anytime when you're burning out in the field, there's a lot of confounding factors, right? We wanted to try to control for as many variables as we could so we could isolate seasonality as our variable of interest. So all these burns were conducted under similar KBDI, right? Fuel moisture was similar, wind was similar. The main difference here was the season in which they were burned, right? So those early growing season burns, it was warmer, your days were longer, but those were your 2 main differences. Getting into some results, so one of the things that we had to do before these fires was put out these arrays of thermocouples. And what a thermocouple is just basically a device that measures temperature. And we're using those thermocouple data as our proxy for fire intensity. So I remember vividly Duck's Nest Gap and some of these other burns going out at like 4 in the morning and burying these thermocouples, the little wires sticking out of the ground, because we had to be out of there at like 9 o'clock because Nick's, he's about to light it up. And we put out these thermocouples and they log temperature as that flaming front moves across. And there's some really interesting things happening if you look at this. Fire intensity was much more variable in the early growing season. You get hotter temperatures later in the burn day. So again, our fuel moistures towards at the beginning of the day were similar, right? But that day warms up faster, the sun gets up at a higher angle, you don't have complete leaf out yet, so those fuels dried out more over the course of the day. And what we see over the course of the day is what you see in this green line right here. This is the average of our of fire intensities for our 3 growing season units over the course of the day. And as you can see early in the day, fire intensity is comparable to what you would see in the dormant season units. But it gets more and more intense as the day goes on before tapering off. And we just didn't see that range in intensities in the dormant season. So you have this greater variability in fire behavior, fire intensity in these growing season units. We had areas that burned pretty hot. We might have got some thermal thinning that we'll talk about here in a minute. We had some areas that didn't burn at all, really, in both of these treatments. But we think that this greater variability in fire behavior and fire intensity is going to translate into greater variability in fire effects. It might promote some community and stand level heterogeneity that might benefit wildlife and many other things. Looking at fuels, excuse me, there were no big differences in fuel consumption between early growing season and dormant season treatments. I mean, on average, it was a little higher, although it wasn't statistically significant in the growing season. Just looking at litter, we burned off about 2 inches of litter in the early growing season compared to about 1.3 in the dormant. But again, getting back to some of that variability in effects, we saw a wider range of litter consumption in the early growing season. That range, which represents the difference between your maximum amount of consumption and your minimum, in the early growing season was pushing 6 inches. It was about 4 inches in the dormant season. This is just the fuels data. If you want to find out more about this, Matt Vaughn's paper just came out back in December. I'd be happy to share that citation with you if you'd like to see that. We see similar patterns for 1 hour and 10-hour fuels, no real difference between them. Nothing that was statistically significant, a lot of variability. But what about duff? Another one of the consequences of fire exclusion is that you get a lot of duff buildup. Right, duff being that layer of partially decomposed organic material right below your litter. And normally in a prescribed fire situation, we're burning under conditions where your duff doesn't really get consumed. And in fact, we measured a lot of duff. We measured it in a couple of different ways. In the dormant season units, we didn't see any duff consumption at all. Not a single point where we measured duff was the duff even touched in any of those 4 fires. In the growing season units, we did see some evidence of duff consumption in a very small handful of our plots. Again, most of them didn't touch the duff, but we had a little bit of duff consumption. And you got to be careful with duff consumption. You don't want to just burn off all your duff, right? Because you got a lot of fine roots and mycorrhizae that are in there. But you do need to figure out a way to reduce it. Chipping away at it just a little bit might be one way to do that. And so we did touch the duff just a little bit in the growing season. So those are just a few highlights of the fuels and fire behavior stuff. Again, Matt's paper came out not too long ago, and I'd be happy to share that with you if you'd like. Let's look at the vegetation, though. So we collected vegetation data before these fires, and we put out a bunch of plots. And then we came back and collected vegetation data in those same plots in the second growing season after the fire. So not right after the fire, but in the second growing season after. Let's look at some of those results. Actually, this picture really is worth 1,000 words. You can see a lot going on in this picture. In our region, in the southern Blue Ridge, back in a previous era, a lot of eastern white pine was planted. Y'all are probably familiar with that. And we're pretty much at the southern end of the range where eastern white pine would naturally occur, right? And where it would naturally occur would be mostly alongside streams and, protected moist slopes and stuff like that. But a lot of it was planted off-site, planted in the kind of places where it wouldn't normally grow. And then it has even spread, on its own beyond those places. Well, when we put fire on the landscape, especially those early growing season fires, they did a pretty good job of killing some surprisingly large off-site eastern white pines. So that right there in the middle of that one that you can see right under the S and the U in results, it was about that big around, about a 10, 11-inch diameter tree, killed by an early growing season fire. That big one behind it, to the right of it, wasn't killed, but it wasn't killed immediately, but it's dead now. And then right below it, you see some mountain laurel that has been thoroughly scorched and top killed. Our biggest impacts on vegetation with early growing season burning were in the mid-story. Again, a consequence of fire exclusion is that you get this dense mid-story comprised of a lot of different things, but largely species like mountain laurel and red maple and stuff like that. So I wanted to focus on those two species, looking at the change in density, this would be stems per hectare, across different size classes for red maple and mountain laurel. So we'll start with red maple, looking at all, right? So I've got 3 size classes. Basically, our mid-story is defined as anything above breast height but smaller than 10 centimeters in diameter. So I've got 3 size classes: less than 3 centimeters, 3 to 6 centimeters, 6 to 10, and then all, right? This is just all of them, right, in the mid-story. And burning in general seems to knock back our mid-story red maples, and growing season burning especially seems to do it. We saw significant reductions in mid-story red maple density when we burn in the early growing season. Now we look at mountain laurel, something kind of similar going on, although they weren't necessarily statistically significant. In the absence of fire, mountain laurel tends to get even more dense. Now this is a little bit dramatic. Like, how did we get 500 more stems of mountain laurel per hectare just from pre-fire to post-fire in our controls? What really happened is, to become a mid-story shrub, you've got to get above breast height. So we had a lot of it before the fire that was about this high, and in the absence of fire, it got this high. And so it became a mid-story species, so we had to measure it. So what you're seeing for the controls is a little misleading. Those increases probably weren't as dramatic as they actually look. But it increases in the absence of fire, decreases with fire, and decreases the most among your smallest size classes, and especially in the early growing season. Got something totally different going on in the understory. Understory is everything below breast height. Understory density of plants increases with burning, increases especially with early growing season burning, especially among that forb and graminoid group. Forbs being just your broadleafed herbs, graminoids being your grasses and sedges. And then just your total understory density increased with burning and increased the most with early growing season burning. So total being just the sum of all of these different categories. But again, pictures are worth 1,000 words. I want to show you all this. This is just pictures of our fuels plots. So you can ignore the browns transects that are running across here and just pay attention to the understory. And think back to what we just learned about deer and what deer like to eat. All right? There's nothing going on in the understory here, hardly anything. This is before the fire, very sparse understory, just a scattered plant here or there. This is one of our growing season units in the Andrew Pickens Ranger District of the Sumter National Forest, pre-fire. 2 growing seasons after the fire in that same unit, not in the exact same spot, but in that same unit. This is what it looked like. So we punched some small holes in the canopy. We'll more on that later. Burned off some litter, touched the duff a little bit, and that's how the understory responds, right? Tremendously lush and diverse understory, grasses, sedges, forbs, seedling trees, you name it, just almost 100% understory coverage, including a lot of light-demanding species that you just wouldn't see in that dense, closed canopy forest. So I would look at that as a positive, right? That understory response. That's what I like to see. Looking at those 2 species that we talked about in the mid-story, now this is interesting. I'm going to have to break this down real quick. Starting with red maple, in the understory, we looked at woody species in 3 different categories. We looked at germinants. Right, that's that current year, that's a plant that germinated this year. Right, those little tiny red maples you see sometime about this big. We looked at established ones. Those are ones that germinated in a previous year, right? They've got multiple nodes, but they're still in the understory. We looked at sprouts, right? Usually when you burn, you top kill stuff and then they sprout back. And then here's all, right? This is your total category. So red maple's wanting to increase. And you see that looking at just that all category. Red maple is increasing in the understory in our control treatments. It's even increasing in our dormant season treatments, but staying pretty close to 0, almost no change in our growing season burn treatments. So you've got for some of your categories, red maple's increasing in the growing season. In other categories, it's decreasing. We did get a good many germinants, current year red maples in the early growing season treatments. But where we see the difference is in these established red maples. And this is something that I've seen anecdotally a few times, but now it's starting to make more sense to me when you think about the reproductive phenology of red maple. Like, when does red maple flower? It flowers early, right? It's one of the first trees to flower. Depending on where you are, it might be flowering as early as February, and then it drops its seeds really early, right? It might be dropping its seeds in early April, depending on where you are. And so I've wondered oftentimes, if you're burning in the dormant season, are you just preparing the seed bed for all the red maple seeds that are about to fall? If you burn in the early growing season, you're burning right after they fell. And if one of your goals is to try to control red maple, let's start by burning those seeds. Right? Burn right after they fall. Now, let's look at mountain laurel here on the left. Mountain laurel decreased in the mid-story, but increased in the understory. So what's happening there, we're not really killing that mountain laurel with prescribed fire. If you've ever tried to kill mountain laurel with prescribed fire, you know what I'm talking about. You don't kill it, but you make it smaller, right? So we top killed some mountain laurel, and now it's resprouting. And so those reductions in mountain laurel that we saw in the mid-story are offset by these increases that we're seeing in the understory, really in all treatments, but especially in the early growing season. So we took tall mountain laurels and made them into small mountain laurels. But if nothing else, we're reducing that ladder fuel potential. So what does this mean for forest structure? So this is getting into some of the work that Allison did. So these stands hadn't seen fire for a long time, and they were essentially all closed canopy, aside from a few wildlife gaps that were pre-existing, before the treatments were implemented. And so in Allison's work, you can look, this graph on the left shows the change in closed canopy conditions from before the fire to after the fire. And what she did here is just looked at pre-fire imagery and then compared it to post-fire imagery and looked for new openings that were created. So we saw almost a 9 to 10% reduction in closed canopy conditions in the dormant season treatment. About half that, in the growing season treatment, and about half that in the dormant season treatment. So these early growing season burns, probably because those differences in intensity that we saw when they burned across that landscape, did a better job of punching some small holes in the canopy. It's still mostly closed, but some small holes, some small gaps. And that's what this figure here on the left shows. This is just one of our blocks. We've got one of each of our treatments represented one time. Control up there at the top, growing season there on the left, and then dormant there on the right. And everything that you see in color, each one of those little colored polygons, is an area that was closed canopy before the fire and is now not. Right? But there's two colors. There's yellow and then there's blue. So what that blue represents is what we're calling open forest. So those are forests with 30 to 60%. Those are patches that have 30 to 60% canopy cover. So everything in blue is 30 to 60% canopy cover. And the changes in forest structure that we saw in the dormant units, it was all that. Right? We were able to create little small patches of open forest. But in the growing season, we also have those patches of open forest, but there's more of them. But then we have those little yellow polygons. And what those yellow polygons represent is areas where you have 30% or less canopy. Right? That's early successional type habitat. All right, so we'll talk about the wildlife implications of this here in a minute. But I think what's going on here, if we're just from a vegetation standpoint, thinking about one of your management objectives, which might be to increase not only oak regeneration, but actual oak recruitment into the overstory. Well, to get oak recruitment into the overstory, one of the things you got to do is knock back your shrub competition, right? Because the density of your oak regeneration is inversely related to the density of your shrub layer. If you got a lot of shrubs, you got a lot of mountain laurel, you don't have a lot of oak regeneration. So knocking back that mountain laurel is one thing, right? That's going to encourage oak regeneration, in the long run at least. And then punching some small holes, not big holes, but small holes in the canopy is going to encourage some of those young oaks to recruit into the overstory. If you punch big holes, you're probably going to fill up the overstory with stuff like yellow poplar, but those small holes might be just what we're looking for to encourage some overstory oak recruitment. Now, we didn't, the time span of this study was too short to see that, but I think if we keep following it, we're probably going to see that in the long run. But Allison's a wildlife biologist. She's an ornithologist. And so she was interested in these changes and what they might mean from a habitat standpoint. And so she developed basically a structural diversity index that she could tell you all about afterwards if you want to talk to her during the break. But what we saw is that control treatment really had relatively little structural diversity. It was pretty much all closed canopy, right? All just one thing, right? The dormant season unit, the dormant season treatments, right? You saw some structural diversity starting to develop because you were starting to see some patches of open forest. But the growing season units had the greatest structural diversity because they not only had more patches of open forest, and then they had those additional patches of early successional habitat that was created. We talked about edges earlier. One of our earlier presenters talked about edges. Very few edges in that control treatment because it's basically all one thing. But as you start thinking about those patches and all of their boundaries and their edges, we saw our greatest edge length being created in the growing season treatment. So what does this mean for birds? I mentioned Allison as an ornithologist. How did the birds respond to these changes in forest structure? These are just a few graphs. She's got a whole bunch of them that we'd be glad to share if you're interested. But one of the first things that Allison did is, well, she went back, I think this was in the third growing season after the treatments, is that right? I think so. I think it was the third growing season after these treatments were implemented. And she went out and did some bird surveys. And she broke out the birds into different nesting guilds. And obviously, anytime you're talking about burning during the early growing season, the elephant in the room is what about the ground nesting birds, right? Turkeys, essentially. What we found is that while there might be some immediate impacts, right, during the fire, and we can assume that there probably are some immediate impacts on the ground nesting birds during the fire if you burn during the early growing season. You see in the aftermath of those fires in the subsequent years, those ground nesting birds respond really positively to those changes in habitat. Right? We saw the greatest abundance of ground nesting birds in our early growing season treatments. We see something similar going on with our cavity nesting birds. They also responded positively to early growing season treatments because we killed a few more trees, right? We created some new snags for them to make their cavities. Again, pictures. Just to give you an idea, one of our growing season units is here on the right, and then we have a control there on the left. And I don't know how well you can see it, but there's several turkeys right here. Right? This was taken in the first growing season after the fire. So this was just a few months after one of those growing season burns. And those turkeys were really taking advantage of that habitat that was created. It was starting to sprout back. They were roosting over on one side of the road and doing their thing, feeding on the other side. So I think that really drives home the point of, one, burning in general creates that habitat heterogeneity that all sorts of wildlife needs. And even some ground nesting birds might really benefit from early growing season treatments. Species richness. So Allison looked at bird species, including a lot of neotropical migratory birds, both during the migration period and during the breeding period. And again, we see the highest species richness of birds in those sites that were burned during the early growing season. So all sorts of wildlife appears to be responding favorably to these changes in forest structure brought on by the early growing season. So I don't know how I'm doing on time. But I wanted to just talk about what this means and what it doesn't. I think collectively, when you look at this, the story that I'm getting from it is that growing season burns are a viable option for southern Blue Ridge forest managers. They're going to reduce fuels just as well as a dormant season burn will, maybe even better. They're just as good, or maybe even better, at controlling undesirable species, and probably better at promoting the establishment of some of those desirable species, particularly if we're talking about herbaceous species in the understory, right? They create more habitat heterogeneity, little patches of early successional habitat, patches of open forest in this embedded in this matrix of otherwise closed canopy forest. You've got all that edge length. And if nothing else, again, if you're looking to expand the pace and scale of your burning programs, I think this says that that's an option. Early growing season burns are an option to consider. But there's some caveats. I think we obviously have to be mindful of wildlife, right? I've got some land that I would love to burn in the early growing season, and then I found that I have this huge, like an unusually large population of eastern box turtles. And I just read a paper not too long ago that talked about how eastern box turtles really suffer when you have in an early growing season burn because they're also breaking dormancy, and they don't do a very good job of getting out of the way. So you might have some reasons. I guess what I'm getting at is why you might not want to burn during the early growing season. And you have to weigh those against the potential benefits of burning in the early growing season. For many of y'all, the decision might be obvious one way or the other. But the big thing is, if you've got a stand that you need to burn this year, the last thing you want to do is pick a date on the calendar in late April or whatever and say, I'm going to burn it this year because I want to create some gaps, I want to get some edge length. You don't want to do that. If it needs to be burned this year, you need to burn it this year. Burn it this year when you can, right? But if you want to incorporate early growing season burns into your burn program, just think about that on into the future. Whatever your burning program is, right, you're not going to accomplish it with one fire. It's going to be an ongoing thing, and perhaps early growing season burns, an occasional early growing season burn, should be part of your long-term plan. So that's all I've got. I want to end with this right here. I've just got two pictures. The first one is our first fire, the Russell Mountain Fire in January of 2018. That was a dormant season burn. And then this second one there on the right was our last fire, the Duck's Nest Gap. I believe that was our growing season burn in late April of 2019. So that's all I've got. If anybody has any questions. Yep.
A first entry burn never being burned.
Okay.
Come in during a growing season versus a first entry dormant fuel reduction moving into your second entry growing season.
Oh, that's a really good question. Off the top of my head, not that I know of. I will say that for all practical purposes, these were first entry burns. I mean, within some of these units, there were some smaller, older burn units nested within them. But off the top of my head, I don't know. I do know that two of our growing season units, the two in the Andrew Pickens Ranger District in South Carolina, got burned again in the dormant season. So some of them have already been burned twice. We haven't had a chance to go back and look at the effects, but that's a really good question. Yep.
You almost answered my question. What about carrying this forward so you had a whole burn regime?
Right.
And you can look at it in a longer context.
We would definitely like to do that. You're only going to accomplish so much with one burn, regardless of what season that you burn it in. We do have a site, the Southern Appalachian Fire and Fire Surrogate Study site, that we've burned 4 times in the last 20 years. And if we think about trying to get more funding to continue that project, I am going to propose that we mix it up a little bit. All of the previous burns were dormant season burns, so maybe in our next cycle of four burns, maybe we try to put one growing season burn in there. I would love to keep it going to see what the long-term effects are, especially when we talk about things like oak regeneration, because the immediate effects on oak regeneration were pretty modest. I mean, there were really no treatment effects, but I think we created a situation where some of them might recruit to the overstory, but we won't know unless we can actually go out there and measure it. Yes?
The question that was in general for this whole day is, you mentioned that 1 million. You mentioned 1 million. It was about acres a year being burned, but there's 16 million that's still around. I was wondering, because a lot of time they were talking in the webinars I've listened to, that in the past, like back hundreds of years ago, they were burning all the time or something like that. And we're trying to return it back almost like that to a certain extent. And so, do you know back in those days how much they burned every year? I mean,
When you
know what the goal is?
When you say in those days, are you referring to like when the like indigenous burning?
Yes.
Yeah, that's a big question that we don't really know. There's some information that we can gather from fire-scarred trees and things like that. And we can tell that fires happen pretty often at relatively short intervals, at least on certain places on the landscape. But in terms of total acreage burned and what didn't, that's a big unknown.
Okay.
but I think we can probably assume that it was more than what's burning now. Yep.
This is a gift bag from the council for you.
Okay, thank you.
Thank you, Don, and let's give Don a hand.